Start the recording. Yeah, because I definitely agree with you that might be a good thing to put on a resume. All right, that's going to be on the first part of this. Okay, I'm going to go ahead and kind of get rid of everything, of all these layers that I've just thrown in here. Different years I've experimented with different layers as part of that beginning part. So I didn't use the Canadian geese observations or the National Park Service land, but you could use those just as you did, just as we did with some of the other layers. The Canadian geese observations came from a nature website. So this is like actual people that said, yeah, I saw Canadian geese right here.
Okay.
So this is the year recorded by the different observers. So you could calculate the density of Canadian geese observation by county or something. All right, delete that one. So let's go to the lab assignment and talk about what it is and see if anybody has any questions or suggestions about starting. And then I'm basically going to leave you all to complete this beginning part, and then I'm going to talk a little bit about we'll do the beginning of this part 2 together, basically. Okay. So we're going to use ArcGIS Pro to complete this lab, and what I want you to do is to answer the question using ArcGIS Pro, but different people might use different tools in order to answer each of these questions. We actually demonstrated that today in the lab, is that there are a few different tools to answer different questions. Now, almost all of these can be answered with the spatial join. Actually, they all can be answered with a spatial join. But I want you to use like an overlay tool or something rather than the spatial join for at least one of the answers. So you're going to describe the process for answering each of the following questions using concepts we have discussed over the past few weeks. So that just means like a 2 or 3 sentence description of the tools that you ran to run. That's what I mean there. Okay. I want you to record which ArcGIS tools you use to answer the questions. So each tool will require at least one tool, sometimes more. So you could turn in your description as just a 1 or 2 sentence, or sorry, 2 or 3 sentence answer, or you could turn in a model, like a GIS model that you built. So you could turn it in either way. You could even turn in a screenshot of the model that you created rather than the actual model itself, as long as the tool that's used is clearly visible. So you need to turn in an answer for every one of these questions. So there's 1, 2, 3, 4, 5. You need to turn in how you did it. Basically, you need to turn in how you did it for each one. So, all right. Now, in some cases, I also ask for a map. So you need to also turn that in. And in some cases, I ask for the name of a place. And so in those cases, you need to turn in. So for every single one, I want an answer to how you got the answer. And then sometimes I want a map, and sometimes I want the name of the place. And I'll specify that in the question. Okay? So whenever I ask you for a map in this course, I actually want an image or a PDF, like an image meaning a PNG or a JPEG. I do not want a map document. So don't send me the MXD, or in the case of ArcGIS Pro, the ARPX file. Like, I don't want to have to open it up in ArcGIS Pro. I want the actual output of the map. So the way that, just to be clear, the way that you do that in ArcGIS Pro is that you go to Share and say Map, and you export it, and you'll get, like I exported these from here, but I'll just go ahead and do this map test 1, and it has to be at least 300 dpi. Okay. So I'm going to export this guy into my pictures, and I should see under pictures, I get an export. So there's my map. Now it's kind of unreliable doing it that way, but you're welcome to experiment and kind of see how it's a totally different area. It was like this area, and I'm not sure how to get it to show the same exact area between the two maps. Okay. However, one thing that you could do that is the best practice anyway, this is the best way to do it, is instead of exporting the map itself, is to make a layout. And so that is under Insert. You can say you want a new layout, and you can do whatever size paper you want since you're going to export the layout to be a PDF anyway, or a PNG or a JPEG. So here I can say I want a new layout, and I want it to be, I'm going to go with a landscape because I'm making a map of the United States here. So now I've got my layout, and what I need to do is I go up into the Insert and I add a map frame. I'm just going to use the default extent and add a map frame, and my map frame is going to be the same map. So this map is the map from here, okay? Although it's a totally different extent. But I can, sorry, I didn't mean to do that. I can go into here and I think I double click on it. How do we get into it again?
You just go in there and type snip and go down there and take a picture. It'll just grab the whole picture.
Yeah, you could use the snipping tool, but I want to show. Oh, that's how you do it. You click on it, right click on it, and you say open. And when you open it, let's see if that affects. No, that doesn't affect it. Yeah. Okay, there we go. Right click on activate. Yeah, that's it. So when I right click and activate, it's not open, it's activate. Sorry. So now I can zoom in and put it where I want it. And if I had different layers on here, they would also show up. Okay. Trying to get just what I want. Play around with it. It's hard to do without a real mouse. I'm using my trackpad. Anyway, let's just say that's the way I wanted it, even though it's not. It's a little bit easier to do with a mouse. Now, if I want to get back out of the layout, I'd press this button, and then I could add things like a legend. I could add a scale bar, whatnot.
Once you get out of it, it's locked into the zoom.
It's locked to that zoom, but I can always edit it by going back in to activate again.
Okay.
So now I can change the zoom level.
And will the see how your box is in that proportions? Like if you stretched it to take up almost the whole page, would that distort at all?
You mean like if I want it to be smaller?
Well, if you wanted it to be more of a rectangular
Like that?
shape. Yeah. So
it won't change the it might change what's in the map, but it won't distort the.
Oh. Okay.
Yeah, it's basically making the window to the map smaller. Okay. Yeah, so now if I wanted to add a scale bar down here, I could. That's a horrible scale bar. But you have to change all the parameters that you'd want to change to get that. All right. Now, if I go to share and I hit export, I will get it'll reliably get the entire area. Did I say 300 DPI? No, it said 240. I'm going to do 300 and hit export. And I reliably get, sorry, wrong window. I reliably get the entire area. Let's see, this area was white down here. It's hard to tell in this program, but this area is white down here. I get the entire area that I wanted mapped. So I have that. So that's what I mean when you need to create a map in the lab, is that you create a map like that. So let's look at the questions here. So which city So remember, cities is in. I want you to use these guys. So let's go back to the map. These are the cities. So I'm gonna add city here. That's the only cities in here. It's actually called large cities. So I want to ask, which city has the most tornadoes where any part of the path is within 5 miles of its center? How about within 10 miles? So you need to answer that question. For this one, I want you to come up with 2 different ways to answer. The rest of them, you don't have to do that. But for this one, I want you to come up with 2 different ways to answer that question using ArcGIS Pro Tools. ArcGIS Pro Tools. The criteria I will use to determine if there are truly 2 different methods is that one of the tools that you use in each of your methods must not be used in the other method. So you might use 2 tools to answer the question, and then another 2 tools to answer the question. Only one of the tools has to be different. So if you use tool A and B and tools C and B, that's fine. That fits the criteria. And one of them can be spatial join. Okay. In fact, we talked about this earlier in the class, how we could do it, but this is actually very similar to the questions that we've already done. So what was another tool that we used that did proximity analysis?
Buffer.
We did buffer, right? Any other tool that did proximity analysis that I demonstrated earlier in the class? Near. Yep. So I can think, in my head, I can think of a way to do this with near, and I can think of a way to do this with buffering, and I think it'd be a little bit easier in this case to do with buffering. And then I definitely can think of a way to do it with spatial join. In fact, let's do the spatial join one together, so we get one more practice doing spatial joins. Okay. So here, what's the other layer that I need besides cities?
Tornadoes.
Yes. So I'm going to drag tornadoes on here. I get a bunch of tornadoes, and these tornadoes actually represent tornado paths. So this tornado went for like a really long time right through there, right? And this one did too. And some of these tornadoes, they just barely did anything. They're like really small tornadoes, little baby tornadoes. They also have attributes associated with them. Here we've got the magnitude of the tornado. We've got the injuries, the fatalities. Here's the loss. I think the loss is like multiplied by. So this is just a loss code. I don't know exactly what that means, but it's not just in dollars, because obviously $4. Oh, we go. $4 worth of loss. Yeah, it could be structures. We have to look better at the metadata. But anyway, we've got all these attributes, and we want to answer the question here: which city has the most tornadoes where any part of the path is within 5 miles of its center? Okay.
The
So
points are the center of the cities.
yeah, the points are already the center of the cities. Exactly. So the points represent the city center. Sorry. Okay. So if we do this as a spatial join, which layer is going to be the destination, or as ArcGIS calls it, the target? Or sorry, I didn't do join. Spatial join. What's that?
Cities.
Exactly. Why? Why are the cities the target?
Because you put the tornado data into the cities.
That's exactly right. All right. So we need the tornado data to be the other one. And as I said, usually you do this 1-to-1. What we're going to do now, what are we doing here? Are we taking all of the tornadoes and joining them to the cities, and every combination will be one, or are we going to summarize the tornadoes as we join them?
You're only looking for the ones that are within 5 miles.
We are only looking for the ones within 5 miles. That's right. But we're summarizing those within 5 miles. So 1 to 1 is the right answer there. And then how can we do within 5 miles? Well, there's a spatial relationship for that. So we go within a distance, not closest. Why wouldn't closest work?
You just take one tornado.
Right. We want to do within a distance. I don't really mind whether you do geodesic or within a distance. Geodesic now is going to produce a slightly more accurate answer. I did choose by the way, one of the things that's important to remember is when you're doing spatial relationships, especially ones that go with distance, it's really important what map projection you've chosen. Because if you've chosen a map projection like Mercator, your distances get distorted as you move north. So 1,000 meters down in southern United States is going to actually be different than 1,000 meters up north. The 1,000 meters up north is going to be more off. It's going to be a greater distance in real life than 1,000 meters down closer to South Texas or South Florida, because that's what the map projection does. So it's best to choose a map projection that distorts distances less if you're going to do a distance spatial relationship. So let's look at what the coordinate system is. I chose the USA contiguous Albers equal area conic. Might have even been better to choose a equidistant projection, but at least this one tries to not distort area throughout the USA contiguous area. All right.
But since the map units are in meters, should we do our? That doesn't.
It just does the math for us.
Oh, okay.
Yeah. So yeah, in some software you might actually have to do that, but in ArcGIS it already has it. So why not do that math for us? So in the background, it's going to convert. What did I say? 5 miles. Yep. Okay. So for this first one, we don't really need to change any of the attributes here because we're mostly just interested in that join count, right? We just want to know how many there are. We don't necessarily care, we could take the magnitude and find out what the average magnitude of all of the, the average magnitude of all of the tornadoes within 5 miles. But it doesn't really matter. We don't need that. So, well, that's what I'm trying to say. Is what we're really interested in is join count. So if I run this, I run it. Okay. Now, how do I answer the question? I want to know which city has the most tornadoes within 5 miles of that city. I have the answer in that attribute table, but how do I actually get it?
Well, you got to go to your join count, and you can set ascending to descending or descending to ascending.
Yes, exactly. So we go to join count. That's in the middle somewhere here.
No, it's to the left, I think.
To the left.
Not all the way to the left.
Yeah, it's like right after it's right in between the two data sets. So these are all the tornadoes attributes. All these lowercase attributes are the tornadoes attribute. These are all the census attribute. Where'd it go?
It's all the way at the front.
It's all the way to the front? Oh, it's right there. Sorry. So we sort. So which county has the most tornadoes? Which city? Sorry. Yeah, St. Petersburg, Florida, right there.
That's a surprise. You think it's like some Oklahoma city or something.
You might think that, right? Now, what's the name of the hockey team there?
Lightning.
Yeah, the Tampa Bay Lightning. Is that right?
Yes.
And then isn't there anyway? I don't know all the teams there, but yeah, this area does actually get some storms. So 45 tornadoes in that area. All right, now we could do modifications of this where we said, okay, well, we're just concerned with the very biggest storms. How would we have done it if we were to ask the same question but say, I only want to know how many magnitude 5 storms, and there is a magnitude 5 here. So under magnitude, see this column right here? How many magnitude 5 tornadoes were within that area? How would I have done that? Or let's do a time slice. Maybe I wanted to know how many, which one got the most tornadoes in 1957? How would I have done that? Both. I would do both the same way. What do I change? What's a way I could do that? I can't do it now that I've already done this, by the way. I have to go back to the beginning. So don't look at this table. How could I have created that answer though? I want to say how many tornadoes were within 5 miles of every city in 1957?
You have to go back to your output fields where it says year and go in there.
Yep. So I go here under year, and I would select just those that have 1957. So first I could run a select and give it the tornadoes, and then call this tornado select underscore 1957. My new expression is year is equal to 19. I'm afraid there's not going to be that many tornadoes, but we'll find out. Run it. Okay. So yeah, here's all the tornadoes in 1957. Not a whole lot of them. Okay. So now what would we do next if we wanted to say how many occurred within 5 miles? We could run that. We could run the spatial join again. In fact, I want to find, under catalog you go to history. Let's go back to this spatial join that we created before, and instead of choosing join features, we could choose, tornadoes, we could choose tornado select 1957, and then change this large city spatial join 1957. So we could run the tool exactly the same way as we ran it before. We don't have to change any of this other data. That's the advantage of using history. Run it. And we look at the attribute table. And in the attribute table, here we've got our join count. We're going to sort it. And we do still have a winner, but just barely. Jacksonville had only 3, and it had the highest. So in 1957, there were 3 tornadoes within 5 miles of Jacksonville city center.
Which is opposite of in St. Petersburg. It's on the east coast.
Yeah, it's interesting though. It's still in Florida, where everybody, like I grew up in. I already told you I grew up in Orange County, but until I was 11, I lived about right here in unincorporated St. Charles County, and I remember tornadoes. Like I remember going under the desk and doing this and seeing tornadoes at school. I was only 11 when we moved, but that's more typical tornado alley, right? You think of that as tornado alley, the Midwest. And there are.
I don't think of Florida when you think
of tornadoes. Yeah. Now, once I moved to California, I really wasn't worried about tornadoes. Look, they call these tornadoes, but let's see if they're even. So, what's the magnitude of that tornado? 0. So it was like not even a scary tornado. Magnitude. That one's a 2. That's probably. I wonder what year that was. EF5, EF2 tornado in 1982. I still lived in Missouri until 1987. So I guess I don't remember that one. All right. Okay, so let's go back. So you would describe that you used spatial join to answer that, and then what's the answer here? Is it? Am I asking for a map? No, I'm just asking for a city name, and so the city name for 5 miles is not Jacksonville, because this is for all tornadoes. St. Petersburg, right? So we'll just do that again, 10 miles. In fact, you could actually just rerun the tool, since I'm not asking for anything. You could just. I always like to clear my selections before I run it again. So go back to history, which is under catalog, history. Rerun the first spatial join, not this spatial join, because that one was on the other one. If you rerun that one, all you have to do is go down here and select 10 miles instead of 5 and rerun it. And now we open up the attribute table, sort it, and what's the answer? 102. Pinellas Park, also in Florida. In fact, it's right across the bay from St. Petersburg. Well, actually, no, sorry, not even right across the bay. Just the next town up. Okay, so those are the answers for those two, but you have to come up with a different way to do it. So you'll know that you did it if you get the same answer using your other method. The buffer is one way to do it. You could do a buffer and then do something else with that buffer. You can do a select by area. Yeah, go ahead.
Do you want us to turn in a Word document, like copy your questions and words and answer them underneath it, or?
Yeah, that'd be fine. Yep. So you have to describe how and why. So for the rest of these, you don't have to find 2 different ways to do it. So if applicable, for all the remaining questions, you should count a tornado as having occurred in a county if any portion of the tornado occurred in that county. So now you're going to answer the question, which U.S. county had the most tornadoes in the 90s? Okay. So we already kind of did something, but where we did that. So what were the 2 tools we ran to answer the question that is kind of like that? Select. Now your select statement is going to have to be different, right?
We have to do all the 90 years.
Yep. Select. Is it in the 90s? So you're going to have to come up with a way to write your select statement. You know, you can work together or figure that out through the help, but there's definitely a way to do that. So which U.S. county had the most tornadoes in the 90s? So that's not asking for a map. Which U.S. county has had the greater amount of loss, there is a loss field, for all tornadoes over the time period? So here, I do want you to turn in a choropleth map with the legend showing the loss totals by county. So here, you're going to have to do a spatial join, but when you do the spatial join, instead of just getting the join count, you're going to have to go to loss field and summarize it. So you're going to summarize the loss field, and it'll give you the total loss for each county.
And that's not in dollars, right? That's just...
Yeah, it's not in dollars. It's just in something that we don't know, some scale we don't know.
Okay.
Yep. But we already demonstrated that. That's what we did with the map of hail. We already demonstrated how to do that, but the way that you do that is you go under loss. Show you here real quick again. Under loss, instead of choosing merge rule first, you choose merge rule sum. So the merge rule says how it's going to be aggregated. So the default for everything is first. In other words, what it's doing is just taking the very first record, and you're getting all of the information from the first record that it encounters that matches the criteria. So if you select sum, it's summarizing that data. So here, I'm answering the question. I'm going to run this. I'm answering the question, which city has the which city has the most loss within of tornadoes within 5 miles? That's what I'm asking. I want you to turn that into which county has the most loss. So now if I take loss right here and I sort it, now the city that has the most loss within 5 miles over the total time period is actually Albany. Okay? Albany, Georgia. So they must have had a lot of big tornadoes there or something. Okay. All right, so that's how you'd answer that. But that's not the right answer to this because this is counties. Okay. How much land area in the United States is within 5 miles of any EF5 tornado that has occurred since 1950? Okay. So this one's actually not used. I think the best way to answer this would be not using a spatial joint. It's kind of like last week. Okay, think how you do that. It's probably a buffer and an intersect. That's a clue there. So turning a choropleth map with the legend giving the percent of land within 5 miles of an F5 tornado. How do we select out just the EF5 tornadoes? That's the magnitude field, by the way. Okay.
Select?
Yeah, select. Use the select tool. But I was trying to answer it with a question. Basically, what I'm trying to tell you is the EF5 means the magnitude field has a value of 5. Okay, how many tornadoes occurred in each county in the month of June throughout all years? Make a choropleth map of the count of June tornadoes by county. So this question right here actually leads in to this part. All right. So for this part, it's going to be kind of a project. This is more of a project. Part 2 is more of a project. So you're going to do something a few different times, and you're going to make a map of U.S. tornado density by month. Okay. So what you're going to do is the first thing that I tell you to do is to use this tool called Generate Tessellation tool to generate 5,000 square kilometer hexagons over the continental United States. That's not something we've covered, so let's go do it together right now. Here I'm going to close all these guys, make this a little bit bigger, and I'm going to add I'm going to actually add the counties back on here real quick because I'm going to use the counties, U.S. counties. So I got all the counties right there, and then I'm going to go back to geoprocessing and go to the tool called Generate hexagons, or generate tessellations. So generating tessellations is a tool that's often done in spatial analysis in order to provide uniform aggregation units. I mean, it's kind of cool to do counties, but the problem with counties we already saw before is that counties are different sizes, they contain different amounts of different variables, and so sometimes it's great to create uniform enumeration units that are the same exact size. And hexagons are actually the most popular one to do because hexagons are the closest shape that tessellates. In other words, you can create a fabric where there's no gaps to a circle. It's the closest thing to a circle that can tessellate. You might have seen a soccer ball before that was all hexagons. They're not always like that. Sometimes they're octagons with squares. But anyway, hexagons. We're going to choose hexagons. And the size that we're going to choose is 5,000 square kilometers. So we'll go 5,000. Oops, that's 50,000, isn't it? And then choose square kilometers. And the spatial reference that I'm going to choose, I'm just going to choose current map. Okay. What that's going to do is keep it in the same projection, which is what I want because we're doing areas. And then this is what's going to save it as. I'm actually going to change this to, let's say, I'll generate, I'll just call it hexagons. That sounds good. Hexagons. Sorry, did you have a question?
Yeah, we used I was trying to follow along.
Oh, drop down and choose current map.
Drop down and use.
Yep. Or you could choose counties because it's the same one.
Got it.
And then under extent, I also want you to put U.S. counties. So what that'll do is it won't create hexagons outside of the extent of the U.S. counties. Now, I'm going to actually take it a step further here in a second, but you'll see what this does once I run it. So I'm going to run this. And now I created the hexagons all over the United States. The problem is that because it's just an extent, there are plenty of hexagons that are going to be part of the analysis, and they're just going to be extra weight because it's just going to take longer to do any of the analysis. I actually want to remove the hexagons that aren't within the United States. Okay, I want to get rid of the hexagons that are outside of the United States. So there's a few different ways to do this. One is we can just go select by location. I think this is probably pretty easy. So select the hexagons that intersect the counties of the United States. And then I can run this. And now I have just the hexagons that touch a U.S. county. Now, is this permanent file? Is that a permanent file? No. That is just a virtual table. So I need to right-click on hexagons and say Data, Export Features. I'm going to put it in the same location. I'll just call this US underscore hexagons. Oh, sorry. I have to put that here. US underscore hexagons. I don't need to change any of the other information. Hit run. And finally, hold on here.
Let's take out hexagon.
Oh, yeah, there we go. Finally, I have just the layer I want. So I can go ahead now and turn and take off hexagons. I don't want to use that layer ever again. I could even delete it. Okay. So now I've got my hexagons. And so here, from now on, you're going to use this layer instead of using counties. Okay. So that's what I did. I did all of this. We did all of this together. So now what we want to do, because we're actually going to do this several times. So that's why I want to create a model. But what we're going to do is we want to create a new layer that will have the weighted count of all tornadoes that occur in each hexagon by month. So in other words, in January, February, March, April, May, June, July, August, September, October, November. So we're going to create 12 layers, and we're going to do a spatial join 12 times. And in each of those cases, we're going to create the weighted count of all the tornadoes. So this is how we're gonna weight the tornadoes. So in other words, if the value of the tornado is -9, or if it's 0, we're going to count that as a 1. If the weight is 1, it'll be 2. If it's 2, it's 4. It's 3, it's 6. By the way, all of these are just double, right? 1. Okay. So we're going to get the weighted count. Now, let's talk about how we're going to do this. So how do we first of all turn the magnitude field into a weight field? So we want a new field called weight. So what are we going to do?
Add a feature class, or not feature class, add a field.
Add a field. So we need to go into our tornado data set, and you need to add a field to your tornado data set. And you're going to call that new field something like weight. Okay? In the tornado data set, you need to do this at the tornado data set. Add a field called weight, and then what do you need to do?
You gotta specify what you want. So I guess you just specify 9, negative 9 and zeros is 1, and then you do a math function for the rest of them.
Yes. Yeah. So then you need to calculate weight into that new field. And as Ashley said, you might need to do that as 2 different steps. Okay? Or you could try to come up with some crazy function that says it in 2 different steps. So one way I might do it is to first of all just multiply everything by 2. So you multiply negative 9 by 2, 0 by 2, 1 by 2, 2 by 2. You just calculate a new field. Everything's multiplied by 2, right? Then you could select anything that's less than 0 and change those to 1. See what I'm saying? So that's how you could. That's not the only way to conquer that problem, but that's one way to conquer that problem. Now, once you do that, you're all set to start creating your model. So your tornado attribute table has to have that new field called weight, and then you can create the new model. And the new model is going to be really simple. It's only going to have one tool, probably. There's a way to do it with just one tool. What one tool do you think that is this week? Well, sorry, there's not just one tool. There's 2 tools. Okay, because you have to. You're only doing it by month. So your tool has to do something to the data to come up with the tornadoes that are only meeting the criteria, and then do another tool that it's going to find the number of those tornadoes weighted by polygon. What tool will that be?
You can select by attribute.
So the first tool is going to be select by attribute. So it's going to be 2 tools, a select by attribute tool that's going to select out if the tornado occurred in January, February, March. So that's going to be the first tool. And then you're going to connect that just with one connection to another tool. What's the other tool going to be? The other tool is the tool we've been using most of the time today.
Spatial join.
Spatial join. So you're going to have a select by attribute to select out January, February, and then you're going to connect that to a spatial join of the hexagons. So and then when you do that spatial join, you need to remember to choose. The when you do the field map, you need to remember to say, I want the sum of the weight field, the new field that you just created. Okay. And once you create that model, you'll just run it 12 times, and you should rename the outputs. You can name the outputs something like hex tornadoes 1, hex tornadoes 2, hex tornadoes 3, hex tornadoes 4, hex tornadoes 5, all the way to hex tornadoes 12. And you'll have 12 outputs, and then your map will look like this. You'll make a map that looks like this with all 12 of your outputs, but you'll have actual locations of where the tornadoes are. Like every polygon will be symbolized as to how many tornadoes there are. See what I'm saying? So you'll choose the sum of the weight field as the output here, and you'll have the tornadoes. Do you think that the tornadoes will change by by month?
Oh yeah.
Yes.
Yeah.
Imagine the weather.
Anybody kind of know what the tornadoes do by month?
They
Really
fall
would
behind
be
like
when
Christmas.
it'd be spring and fall because that's the transition periods.
Yeah, but do they change spatially?
Oh. I know we have like a mini Dixie tornado alley, but I don't know what time of the year it
Right.
goes off.
What time it is?
Yeah.
I
Yeah.
don't think they change like spatially.
Yeah, it'll be interesting to see, right? So we'll see if there is a seasonality to it. Then we should see that seasonality change. Like, in other words, January might have the tornadoes all around here. February they might move up here. March they might move up there, or they might move more slowly. But anyway, that's the thing we're trying to do, is to find out if there's a pattern in terms of where tornadoes are month to month. Okay, so that's the answer that we'll get here when you do that. So anyway, I believe that I walked through the steps pretty well, and it'll all be on the video. But if you have questions, you can ask some questions right now, or I can help you individually as you walk through.
I do have a quick question.
Yeah, sure.
How do you just get all those different maps onto one layout view by just adding maps and just? Because I've never actually
Yes.
made an official map on ArcPro yet.
Right, so you'll have 12 maps, and so these maps are small enough that you could kind of do. I think Elvis was the one that said this. You could kind of cut and paste. Like you could do snipping tools, and you could kind of re-shrink them down. But again, I think that it would be cooler to do it in ArcGIS Pro, but you could use snipping tools. So here, let's say I have a map there, and I might want to, I'm going to activate it and make it the whole thing. And I also want to get rid of the topographic part. Actually, I'm going to remove that layer entirely, because if I remove that layer entirely, the credit doesn't even show up. Okay. All right. And then I can go back to layout, and then I could say add another map frame. Put it right here. And make it roughly the same size. You can actually go in and go under properties, and you can change the location. You can change the scale so that they're all the same. You can change the extent so that they're all the same. But you can. I don't really mind here. This isn't a cartography class, so you can eyeball it if you want. You don't have to do them all exactly the same. I mean, I think it would be cool, but all right. So that's pretty close, I think. And so yeah, you could just place, 12 of these on the same map like that. Now, of course, your map will look different because the polygon, you won't even have, and by the way, here, if I go back to map, and it's not like ArcMap where I turn off these dot layers and I go back to layout. I guess it is like ArcMap. I thought it wasn't. So yeah, the layers will update.
How do you make your second layer be different from your first?
Well,
If they all override, then it's going to be.
yes, you'd have to add a separate map. So
Okay, I got you. So you would just.
so if I add in another map here, if I go back to insert map, new map. So here I've got another map, and I go back to catalog, catalog, and I take my US hexagons. Of course, they'd be all symbolized up, but see these hexagons are now yellow. So now if I go to layout and I insert a new map frame, that's map 1 instead of map.
Gotcha.
So you'd have 12 different maps, and now I can make this the same size. It's easier to make the same size when they're right next to each other. I can always move it later. So that's roughly the same size. And then I activate it and zoom so that it's same. And then I messed up there. Okay, layout. All right, so now I've got 3. You'll just do 12. Okay. Just symbolize them. And then.
Can you drag like your layers from that to the next map? Or,
Yeah, you could. You can take your layers and throw. Like I could throw large cities up in. I think I actually have to do it at, like. I don't think you can drag it, but you can get it over. So I think I have to do it by saying copy and paste. So now I've got stadiums in there, and then it will show up in the layout. So if you created all 12 layers in the same map, you'd have to copy and paste them over into 12 maps.
Doing 12 maps isn't going to make this freeze?
No.
Okay.
Having 12 maps isn't going to make it freeze. And you could save your project a few times while you're doing it, just in case something does freeze. But remember, your data. Even if I didn't have the map, you're probably going to spend about the same amount of time, an hour or two, creating the model. It's going to take like 10 minutes once you create the model to create each output layer, and then you'll probably take another hour or two to put everything in the right place and symbolize the map correctly.
Are you worried about like North Arrow and or anything
No,
like that?
no. I think that I
like the summer and February.
Yeah, I think that the power of the story of this map will be not necessarily. Everybody knows that it's the United States, and so the story will be the differences in the maps and being able to compare them quickly. And so I personally don't think it needs a north arrow, but you're welcome to put a north arrow because they're more like diagrams at this point than maps, but they have spatial.
You want the month placed on the bottom left of each map.
Yeah, you can do that. That's the way I pictured it. I just kind of worked. So January, February, March, April, May, June, July, August, September, October, November, December. And I do realize that, winter technically starts in the third week of December.
Yeah.
Spring actually starts the third week of March and so on. But, it's pretty close. So.
Dr. Ritter,
Yes.
can you go back to where you changed the polygon from the square to the shape of the state? The shape of the United States?
So you're asking how I got it back to. So this was.
You already deleted the hexagon.
Okay. So I didn't actually delete it off the disk though. So you have hexagons.
But I have the full square right now like that.
Like this.
I'm having difficulty with the select by location.
Okay.
To figure out how to get it to just make it.
Yeah, sure. I'd love to. Okay. So select by location is one of the tools that's actually up under map. If you go select by location, or you could just type select by location over here. So either way, you got to the tool though, or no?
Yes.
Okay, so once the tool is open, your input features are going to be your hexagons.
Right.
Your spatial relationship is going to be intersect. Your selecting features are going to be the U.S. counties, and then everything else is just the defaults. No search distance, no new selection. Don't invert the spatial relationship. If you inverted the spatial relationship, by the way, what would this do? In other words,
it did the opposite. It would just give me everything outside.
yes, it would be not intersect. So in other words, if it didn't touch any county in the United States, it would be selected. That's not what we want. Okay, so you hit run, and they all get selected. So now what do? Now you have to right-click on hexagons and say selection. No, sorry, data export table, export features. Sorry, data export features. If you say export table, it only export the attribute data. All right, so data export table, and then choose where you want to save it. So I just wrote US underscore hexagons, and then I hit run, and I'm not going to run it again because it'll overwrite the data. I guess it wouldn't matter, but I'm still not going to hit it again.
No, just hit run.
Yeah. So that answer your question?
I believe so. Let me remove the. Yeah, that did it. Okay.
Awesome.
Now, why is it on that in the middle of the United States? It's like two hexagons. That's just not the United States.
It's the middle of the lake.
Yes, this is the middle of Lake Michigan. So those two polygons don't touch any land. See, if I turn on the U.S. counties and I put them above the hexagons, see there's no, actually that, well, no, I get that polygon, that hexagon right there almost touches Michigan, but it just barely doesn't. And so since the tornadoes, well, the tornadoes actually do go out into the water. But anyway, we're not really concerned about the water parts of the analysis, so that's why that happened. It's just an artifact of how our data was. Yeah.
Thank you, sir.
It's interesting that it just barely doesn't. All right. Any other questions that you want me to answer on the recording? All right, I'm going to stop the recording then.